Okay, so we are going to go through the Unit 7 review problems. And number 1 is asking us to find certain values of lengths and a coordinate. So it says that triangle ABC maps onto triangle LMN with this transformation. So if AB is 9, what is LM? Keep in mind AB is from the first triangle, and we are going to see what would be the new length in triangle LMN. So if you take a look at the transformation, this first transformation just moves it to the left 2 and up 1. It doesn't change the size of the triangle. What changes the size is this dilation. This dilation tells me it's going to be 3 times its size. So to find LM, it's basically taking 9 and multiplying it by 3, which gets you 27. It's 3 times its size. All right, part B. So if we have B as 3, 1, what's the coordinates of M? So we're going to have to go through this transformation here. So if this is the original coordinate, I'm going to go ahead and take the first transformation, and we're going to take the 3, plug it in for x. So 3 minus 2 is 1, and 1 plus 1 is 2. And then we're going to do one more transformation. We're going to take this new coordinate and multiply them by 3. So 3 times 1 is 3, and 2 times 3 is 6. So this is your new coordinate for M. All right, let's go ahead and go to number 2. Number 2 happens to have a triangle inside of another triangle. All 3 triangles in this are actually similar. So what I'm going to do is I'm going to draw all 3 triangles over again, and I'm going to write the side lengths that go with them. Notice this is a long side, this is short side. So I'm going to draw a long triangle. This is QRS, and I'm going to draw a medium triangle that looks exactly like this, but just a little bit smaller. Again, this is the long side, this is the short side. And I'm going to draw the teeny tiny one. Again, this is the long side, that's the short side. All right, now the placement of the letters is probably the most difficult part. So if you take a look at this right here, the long side is QR. We're going to take a look at the medium, which is this triangle here, and then the small is that triangle there. So let's start with the medium. Notice that T is where the 90 degrees is, so I'm going to go ahead and put T here. Now you have to figure out which is the longer side, not being the hypotenuse. Hypotenuse is across from here. So this is the longer leg, this is the shorter leg. So longer is Q to T, and the shorter is T to R. All right, let's go ahead and take a look at this small triangle here. So this small triangle, we want to look at the longer side. Between TS and TR, the longer value is T to R. Oh, sorry. T to R, and T is where the 90 degrees is. And then S is the other side. So T is where the 90 degrees is, and RT is the longer length. Okay, now they gave me some values that are here in this problem. It says that QT right here is 8 meters. TS right here is 4 meters. And what is RT? So here's RT, and here is RT. There's 2 of them. So it looks like we're actually going to use these last 2 triangles to solve for what the length of RT is. So let's go ahead and set up a proportion. 8 over x equals x over 4. And then cross multiply. X times x is x squared. 8 times 4 is 32. We have to take the square root of both sides. And then you can break down 32 to 8 and 4 again, just like we multiplied. And 8 breaks down to 2 and 4. I have a pair of 4s and a leftover 2. So 4 goes outside and the 2 goes inside. So this is our t is. 4 root 2. Now that's not all we have to find. We have to find also what is the area of this triangle. So if we want to find the area of a triangle, we need base times height. Now this is the picture of the big triangle right here. We don't have the base, we don't have the height. So that's probably not going to be the best use of this. But if you notice the picture of this whole triangle here, there is a line right here. And that line right here is really a height. See how there's 90 degrees? If you actually take this picture, and I'm going to rotate it around just to make it so that you can kind of see this. So this triangle right here does have this as the base, and this is the height. So when I find it, I can use 1/2 base times height, and that's what I'm going to use. Okay, because I do have some values that are in this triangle. So I'm going to go ahead and now put in some of those values. Keep in mind, there's t's right there. And it told me that QT was 8 and TS is 4. So we actually know the length of the whole base. The whole base is actually 12 together, 8 plus the 4. And we know what RT is because we solved for that. That's right here, 4√2. So let's go ahead and plug it in. The area of a triangle is 1/2 base times height. We just have to kind of turn it in our mind. So 1/2, the base is 12. The height is 4√2. And now when we multiply it, half of 12 is 6, and 6 times 4 is 24√2. But our units were in meters here, so our area is meters squared. Remember to square your units for area. All right, let's go ahead and go on to number 3. All right, number 3 has a triangle, and it's a special type of triangle. This one is 2 sides equal, which is an isosceles triangle. So I'm going to go ahead and redraw it so I can actually put the values in the picture. So we have K, J, and I right here, and we know from J to I is 10, and we want to find out what is the value from K to J. So that's what we're solving for. So I'm going to go ahead and put X right there. Now, since it's an isosceles right triangle, oh wow, it's not focused. There we go. So we're solving for J to K, which is right here. So now what I'm going to do is I'm going to go ahead and take a look at what kind of triangle this is. If it's an isosceles right triangle, this is one of those special 45, 45, 90 triangles. And so I can use my ratios. If you remember the ratios, the 2 sides are equal. So I'm going to put n, and this side is n√2. This is the one side that I do know matches up. So I'm going to go ahead and use that information to solve. So I know n√2 is actually equal to 10. So to get my n by itself, I'm going to divide by √2, and that's going to cancel. So n equals 10 over √2. But you can't have a radical in the denominator, so I'm going to go ahead and rationalize by multiplying the top and bottom by square root of 2, which gets you 10√2 over square root of 2 times square root of 2, which is 2. But that's still not fully simplified because you notice the 10 and the 2 here are both on the outside. 2 goes into 10 5 times. So actually n is 5√2. So now we know that this length of this side is 5√2, which is JK. And JK is one of the sides that I needed to solve for. Now that's going to help us because not only is it asking for what JK is, it's asking us for what the perimeter is. So since this 5√2 is this length, and this length, because of the fact that they're equal, I can find the perimeter. So the perimeter is when you add all the sides. We have a 5√2 plus another 5√2 plus the 10 on the bottom. These two are like terms. The 10 is not, because 5√2 and 5√2 is like saying 5x plus 5x, and that's 10x. So really that's 10√2, which doesn't go with just 10. So you have to leave the answer separate like that. All right, let's go ahead and go on to number 4. So number 4 is asking us to state all angles that are congruent and all the sides that are proportional. So let's start off with first finding all the angles that are equal. We actually don't need to know what the pictures look like because the letters should be in the same order that the angles line up that are here. So I'm going to start with angle L. That should be congruent to angle P. Those are the first 2 letters, or first letter of both of the triangles. Angle M is congruent to angle Q. Those are the second letters. And angle N is congruent to angle R. That's the third letter. We didn't even need the picture for that. Now to write the proportional sides, we're going to write 3 ratios and make them equal to each other because all of these should be equal. So start with any side of the triangle. So let's start with LM. Notice LM is the first two letters. That goes with PQ in the other triangle. All right, what does that equal to? Let's pick another side, MN, which is the last two letters. And that goes with the last two letters, QR. And you can see that in the picture here. Equals, and then the last side is LN. LN is the first and last letter, and that goes with PR, first and last letter, right here. And that's the proportions. All right, let's go ahead and go to number 5. So Ryan is 6 feet tall. At a certain time of day, he casts a shadow that is 12 feet long, and at the same time, a tree casts a shadow that is 28 feet long. What is the height of the tree? So on this one, it helps to draw out what's going on. So we have Ryan here, who is 6 feet tall. He's casting a shadow. Remember, shadows are on the ground. That is 12 feet long. At the same time, we have a tree. So let me go ahead and draw this tree. And that is, I would say that has a shadow that is 28 feet long. What is the height of the tree? All right, so if you take a look at what the information they gave us the height and they gave us a shadow. We're trying to find what this height is. So we're going to go ahead and set a proportion. And since they gave me height and shadow, I'm going to go ahead and write a proportion of the height to its shadow. You can write shadow to the height. Can I spell? Shadow to the height. So let's go ahead and set it up. So the height is 6 divided by the shadow, which is 12. That's for Ryan, so that's Ryan's set. Now let's do the proportion of the tree. Height, we don't know, over the shadow, 28. All right, let's cross multiply to solve. You can reduce if you want to. Well, it's fine. 12 times x, 12x, and 6 times 28 is 168. Divide both sides by 12, and we get 14. And so the height of the tree is 14 feet. All right, let's find the geometric mean. The geometric mean is when you take the values and you make a proportion out of that. So it's going to be x over a, which is 3/5. And that equals b, which is 10 over 7, divided by x. I know that looks really complicated, but you're still just cross-multiplying to solve. X times x is x squared. That equals 3/5 times 10/7. Notice that you can cancel. 5 goes into 10 2 times. So we have 3 times 2, which is 6 on top. 1 times 7 is 7. To get rid of the square, you take the square root, and it's only positive values. So you can't have a square root in the denominator, so we're going to have to rationalize. Oh, multiply by the square root of 7. We're getting rid of the 7 that's in the denominator. So since 6 and 7 are both in the radical, we are going to go ahead and multiply them together as 42 inside the radical. Square root of 7 times square root of 7 is just 7. All right. Number 7. So this has a lot of those trigonometric functions that we had. So I'm going to go ahead and draw the triangle here first, just so I can write on it. L, T, and F, 90 degrees. This is 6 centimeters and 10 centimeters. All right, so your first thing that you need to solve for is find what LT is. Okay, that's the length down here on the bottom. Now, you can use Pythagorean theorem and go a squared plus b squared equals c squared, but I noticed 10 and 6 might be familiar, so I'm going to draw a version of this that's similar, and I'm going to scale it down. What can go into 10 and 6? Well, they both can be divided by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. Does this look like a familiar Pythagorean triple? This is a Pythagorean triple that's a 3, 4, 5 triangle. 3, 4, 5. So since this is just double the size, 5 times 2 3 times 2, 4 times 2, that gets you 8 centimeters. Like I said, if you don't want to do Pythagorean triple, you can always go back and use a squared plus b squared equals c squared. All right, part B. Part B is asking us to find sine f. So the reason why they have that angle there is so we know what is the reference angle. This is your reference angle. So that way we can label the other sides. So across from angle F should be the opposite side. The side that's next to it, but not the hypotenuse, the adjacent side. This one across from 90 degrees is your hypotenuse. That's going to help you in writing this ratio. So what is sine F? Remember that sine, and using maybe your ratios, SOHCAHTOA, write that out just so I can reference it to this problem. Sine is O over H. So we know this side is O, we know this side is H. That's what I'm going to set up. So O is 8 over H is 10, and that reduces by 2, which gets you 4/5. The next one is to solve for cosine F. All right, so angle F again is my reference angle, so all I'm going to do is a different ratio here, A over H. A is adjacent. Here's my A, that's 6, over hypotenuse, that's 10. And 6 over 10 reduces by 2 to get 3/5. And then the last one of these is to solve for what angle F is. What is the measurement of angle F? I can use either one of these two ratios to solve for it. So I'll do both just to show you that it works for either one. So the first one I had was sine F equals, and you could use 8 over 10 or 4 over 5. Or you can use cosine F equals 3 over 5. You don't have to use both. I'm just showing you that both of them get you the same answer. Now to solve for an angle measure, you have to get rid of sine. And to get rid of sine, you have to do the inverse, which is the little -1. That gets rid of it. So F equals sine inverse of 4/5. So now it's time to plug into the calculator. So we have sine by hitting the second button, and notice now the -1 shows up. 4 divided by 5, which gets you approximately 53.13 degrees. All right, what would you get if you did use cosine instead? Let's see. Cosine inverse. F equals cosine inverse of 3/5. Let's see what that gets us. So then we have inverse cosine. Don't forget to put that second button. 3 divided by 5. And notice you get exactly the same answer. So F is approximately 53.13 degrees. So either one of the two that you want to use. You could have used tangent if you want to. Let me try to get this light to turn on again. Let me work on this for a little bit. It's not turning on. All right, lights on. Okay, last one on this column, I should say. So number 8. Number 8 has given that this triangle ABC is similar to triangle ADB, and then we have AC is 4, AD is 9. We're finding what AB is. So what I'm going to do is I'm going to go ahead and draw these triangles separate. For me, it's easier to visualize. So I have triangle ABC, that's this triangle up here, and notice the letter order. And then I have another triangle that's a little bit bigger. And then you can even notice the order. I went ABC, ABC. This has to be ADB in the same order. Okay? And now I'm going to go ahead and put in the values here. So we know that AC is 4, AD is 9, and I have to find AB, which is either here or here. Notice I have these two sides. I can set up a proportion. So let's go ahead and set it up. 4 goes with x. So 4 over x equals x over 9. So let's cross multiply. X times x is x squared. 4 times 9 is 36. To get rid of the square, you take the square root, and we only want positive values because it's the length of a side. So x equals 6. Okay. The next video will be the next column.